So we're asked to find out how fast this distance is changing because they're telling us the ladder is sliding down. So we don't know either of these two lines I just drew, but the derivative of this side I just emphasized is what we're asked to find because it's growing, right? The ladder is falling down, so this distance is going further back because the ladder is getting pushed further and further back. Okay, so we want to solve for x prime. So we don't know what this is, so we could call this distance y, and we can make an equation involving x and y using the Pythagorean theorem. A squared plus b squared would equal c squared. Okay, so we're looking for x prime from this equation. And if we take a derivative with respect to x, we're not going to get x prime out of it, right? You're going to get 2x plus 2y times y prime equals 0. That's the derivative with respect to x. But the fundamental variable here isn't the x that we define or the y, it's the number of seconds. That's what's governing both of these amounts. Depends on how many seconds we've gone to calculate x and y. So if we take a derivative of this whole thing with respect to t, using implicit differentiation, then we can just plug in the values we're given. So the derivative of this term is 2x, and then the derivative of the innermost function with respect to t is unknown, so we have to use x prime. Okay, so just like when you took a derivative with respect to x of an equation involving y and y prime always came out, we're taking a derivative with respect to t, a different variable, which x and y are defined by. So same thing here, the 2 comes down and multiplies, but the derivative of y isn't 1 this time because we're taking a derivative with respect to t. So again, using implicit differentiation, that's dy. And then the derivative of a constant, doesn't matter with respect to what variable is, that's going to be 0. Okay, now we can plug in our given information. The top of the ladder, so this part, slides down a rate of 4 feet per second. So y is shrinking. That means it needs to be negative. And I'm putting that in for y prime because that's a rate of change of y. And then how fast is the bottom of the ladder, the ground moving when the bottom of the ladder is 7 feet? So the bottom of the ladder is 7 feet from the wall. So the hypotenuse is always 14 because the ladder is not shrinking. We're told that this is 7 feet. So that means x is 7 feet. We can plug that in here. We don't know what x prime is. That's what we're trying to solve for. And we can't solve if we have two different variables, so I can't just put a y here. I can go find out what y is at this instant by plugging in, by using the Pythagorean theorem, right? Because y is whatever the distance is when the ladder is sliding down. And when x is 7, this is a right triangle still, so we can use the Pythagorean theorem. That's plus 49. That's 14 squared. 196. So we can subtract 49 from both sides. That's 147. Then if we take a square root to solve for y, let's see if we can simplify that radical. Square root of 147, if I divide that by 9, no. 47 divided by not 16, not 25, maybe 49. Oh, so we can factor out a 49 from it. So that's 7 square roots of 3. So this number right here for y is 7 square roots of 3. And now we can solve for x prime. Just algebra from here on out. So 2 times 7 is 14. 14 times negative 4. Negative 156. Should be minus, sorry. Wait, that seems too big. 2 times 7 times 4. Oh, not 150, negative 56, okay. Okay, that's a little messy. Let me get my eraser. Okay, that's better. Still solving for x prime, so we'll add that 56 square roots of 3 to both sides. Divide both sides by 14, and then when you simplify that fraction, 56 divided by 2 gives us 28, divided by 7. Oh, that fits in perfectly. Okay, so 56 divided by 14 apparently is 4. So 4 square roots of 3. And it's positive because remember this distance is increasing as the ladder falls down this the side.